All right, so let's do a little summarizing and some commentary from me about the section T4. We'll use our key takeaway slide, starting with T4A. Power supplies. 50-watt mobile radio needs 13.8 volts at 12 amps to match the vehicle's electrical system. So if you decide to run a mobile radio as a base radio, which is fairly commonplace, there's a whole lot of mobile radio options out there, especially at the technician level. That may be all you need for the time being. Then you would have to have a power supply that matched this demand from a 50-watt radio. There are some radios that run a little bit higher power, some that don't run quite as much, but the 12 amp or so, I recommend most folks, if you're going to run a mobile radio at a 50 watt or higher, have about a 20 or 25 amp power supply in your home if you decide to run the radio in your home. And the same thing would apply to the base versions of most of these radios, which are basically just bigger, bulkier radios that may accommodate a desk mic or something like that, require the same amount of voltage for a lot of those. And then if you get into the ones that also have HF and the 100-watt capability on HF, then you'll want that beefier power supply. But for the technician test, the main thing is to remember 13.8 volts at 12 amps. SWR meter selections needs to be based on the frequency range and power level, and this is kind of a crucial thing that a lot of folks may not even realize, especially if you come from the just the one band of like the 11 meter world, or maybe you were GMRS or something like that coming into ham and you've only been dealing with the one band. That was something as a young ham I didn't realize that there was any difference between any SWR meter. I thought a SWR meter was a SWR meter, and as I got more advanced into it, I realized that they were frequency specific. You have to get one that can handle your range of frequencies, but the power thing is the one of the most crucial parts, because if you do get yourself an amp and you try to run 1,500 watts through a 300 watt or 100 watt power supply or SWR meter, then you're going to have some problems. You're going to fry some components and damage even the radio that's attached to them. DC wiring, the short heavy gauge wires minimize voltage drop during transmit. The bigger the wire, the more that it can handle. Small thin wire, you definitely don't want to use anything like the Cat 5 wires or something that thin. The bigger, heavier gauge wire also, it helps to distribute the heat and everything. It doesn't break down as easy under those heavy conditions. So, to minimize the voltage drops by being able to carry everything that it needs to carry. And you'll find too, when you get into coax cable, the bigger it is, usually the more that it will handle what you're putting through it. Digital modes, computer audio in, out connections to the radio, audio in, out, PTT signals, keys to the transmitter. So what they're talking about here, and you'll hear digital modes, even in this section right here, mentioned for two things that are somewhat different. This right here, we're talking about connecting a computer to a radio, either HF or VHF sideband or something like that, and letting the computer talk through the radio and listen to what the radio is hearing. And one of the reasons that these kind of modes came along is it's great for weak signal work. It works when you can't hear things otherwise. Like our human ears can't hear and interpret what's coming across the airwaves, whereas the computer can hear stuff that's down in the mud, down in the static, and if it's sitting in some kind of digital code, it can interpret it. So that's one of the things that helps as far as working DX station or distance stations is being able to send this stuff out in a digital format. CW is kind of the same way. Even with human ears, you can, down in the mud, interpret the dots and the dashes and hear when you may not be able to make out a voice at the same level. RF power meter, you install that in the feed line between the transmitter and the antenna. It's not very practical to put it at the antenna and be able to see what's going on, and most of these meters are not weatherproof or you can stick them out there. You will get a more true representation on that end of the coax, because you'll pick up what's actually making it out to the end of the feed line and everything. And there are some meter options you can get where you can kind of set that up at that point and be able to see it in the shack. But just generally speaking, a RF power meter needs to be in the shack between the radio and the feed line going out to the antenna. bonding. So use a flat copper strap at RF, more surface area due to skin effect. So what has a tendency to happen is if you use round wire, and depending on the length of that round wire, sometimes, especially when you're dealing with HF, that antenna system doesn't know what's what. So you have that the center conductor that goes out to your antenna, but then the outside is also the shield, which connects to the ground of the radio, and all that stuff kind of bonds together, and the signal follows the path of least resistance. It doesn't know, hey, this is the feed line, this is the antenna, this is where I need to go, and there's ways that you can kind of make it do that. But if you use some type of ground wire and it ends up at a resonant point of a frequency that you're on, you can actually be tuning up the ground wire or using it. I know when I first got my upgrade and got on HF, I had a 10-meter vertical antenna, and I just ran a stretch of wire out to my house ground to ground my rig, and you could grab a hold of that wire as I was transmitting and get a little bit of a tingle off of it, depending on where you were at. Battery life, so amp hours divided by average current flow. That's pretty simple. Whatever the amount of amp hours there are in the battery versus how much the piece of equipment is drawing, you can do that simple math and figure out how long is that battery going to last. So that's going to be good for field operations. Mobile ground, connect the negative, return to the battery chassis ground. If you just attach that anywhere, one of the things I used to do is I used to loosen up a seat bolt and just jam it up under there. But one of the problems is doing it that way, you can pick up some of the noise of the vehicle if you do that, as opposed to actually bonding it or putting it with the battery ground itself. So let's look at T4B. T4B, key takeaways: mic gain, excessive gain on single sideband, distorts your audio and splatters. Kind of the same principle if you've ever been into any kind of broadcast or any commercial recordings or anything like that. If you turn the mic gain up excessively, and one of the problems I ran into on HF on sideband is I try to run some broadcast style microphones like the one I'm using now, and sometimes they can be a little hot for sideband, and it distorts your audio, and you have to kind of filter that back or scale that back a little bit. Frequency entry, you can use the keypad or the VFO knob to set your operating frequency. A lot of radios have the keypads now built into the microphones. Several of the ones that I do, you can, if you know you're going to 146.52 megahertz, you can type in 146.52, and then the other option is just to spin the dial or the VFO knob and make your way to the frequency that you're looking for. And on your squelch, open it fully to hear weak FM signals, audio all the time. Sometimes you may have to do that and you get on the fringe area of a repeater, or you're working somebody's simplex like a POTA station or something like that, or a SOTA station. You may have to open that squelch up to be able to hear that person. If you get into satellite work, then that is pretty much how you're going to have to do it. You're going to have to open up the squelch all the way, and you're going to hear most of the signals that you're going to hear from the satellites are going to be below that squelch threshold. So you just have to open it up and listen to the white noise or the static as you're in between transmissions. And then that RIT clarifier, that adjusts the receive frequency to fix the pitch on single sideband without moving the transmit. That comes in handy. Sometimes you have somebody that maybe you need to clarify, as it says, you need to make that signal a little more readable. Maybe you're checked into a net or something and you know you're pretty much on frequency, but this person may be off a little bit compared to everybody else. So you can make that adjustment as needed and not affect your transmitter. This comes in handy sometimes. There's still a lot of old vintage equipment out there where the receiver and the transmitter are separate from one another, so they may be off just a little bit on their transmitter compared to their receiver, so they're hearing you fine, but they're a little off kilter. Well, this gives you the ability to compensate for that and sort of meet them in the middle. DMR code plugs. So this contains repeater access info, talk group configuration. So if you have all the information for the DMR code plug, that's basically their configuration file, and that if you're matching up to what the other person has in their receive side, then you're able to communicate with them. Bandwidth. So 2400 hertz is optimal for single sideband. So it's good to know these these bandwidths, and whatever mode that you're operating in, you can match your filter to the width and mode. One of the things that I don't mess with my single sideband filtering that much. It's usually set right there around 2400 or so, maybe just a little bit above to kind of let a little more in if I'm dealing with some real weak signals. But CW in particular, I'll just throw in there as I'm tuning around and I find that signal that I'm wanting to work, and you watch that waterfall and you kind of center them up where you need them. Then I go down to as much filtering. I think it's like 50 hertz. Then you're pretty much locking in and pinning that signal down and listening to just that one signal without any kind of distortion with somebody who could be just really right next to you. And then D-Star. This is one I'm not as familiar with, so I'm actually, with these newer test questions, learning a lot about it. I don't have any activity on it in my area that I know of, so I don't have any D-Star radios, but it does sound pretty interesting. You absolutely have to program your call sign in before transmitting, because this is part of what they use in their protocol to be able to access their networks. And then FM tuning, off-frequency tuning causes audio distortion on FM. And one good way, if you don't own a amateur radio of any kind, you haven't even bought your first cheap HT or any of that kind of stuff, your AM/FM radio, your car stereo in your car, a good way to see an example of this is tuned to one of your local radio stations. Like in the area I'm in, there's a radio station on 96.9 megahertz. And go up the dial 1 notch, 2 notch, and just listen to what it does to the sound. If you're off by just maybe 1 kilohertz or so, you can still hear it decently. It might throw a little static in, but you can get an idea going up or down around that frequency of what they're talking about right here. And then in this one, just a few study tips to kind of help you out. Focus on those numbers. Memorize key values like 13.8 volts, 12 amps, 2400 hertz, 50 ohms. These specific numbers appear directly in exam questions. Understand signal flow. Trace the path, computer audio out, radio mic in. So whatever's coming out of the speaker jack of the computer needs to go into the microphone jack of the radio for the radio to be able to put that information out over the air and transmit. Then radio speaker out needs to go into the microphone or the line in of the computer if you're making the connection that way. Now, a lot of these things, they just have a USB setup, but you can still do it as we did in the early days by making these connections. So if you go from the output of the radio, either the headphone jack or the external speaker, and you go into the microphone or line in of the computer, then the computer can hear what the radio's hearing with that software. So knowing how that flow works helps with multiple questions. One neat thing that you can do is if you have some kind of receiver, a lot of folks I know out there have them, and they're not as expensive as buying a full-on radio, but you have some kind of receiver where you can listen to the amateur HF bands or something like that, then you can do half of the equation and listen. You can take the line out of that receiver if it's capable of doing single sideband or something like that. Most of the digital modes run on upper sideband. You can plug that into the line in of a computer, download the software that you have to decode that, and you can sit there and you could decode FT8. You can decode other modes. PSK31 is one they don't use as much anymore, but it's still out there. You can download software and decode CW or Morse code signals. So that's a pretty neat thing to be able to do. You can kind of work half the equation just with a receiver. A lot of shortwave folks out there I know are probably capable of doing that and have that equipment. Then 3, learn why, not just the what. Understanding skin effect explains flat straps. Understanding P equals EXL explains power supply ratings. So concepts connect multiple questions together. And then 4, compare digital modes. No DMR for code plugs, talk groups, color codes, D-Star, call sign required, hotspots, internet bridges. Each has a distinct configuration requirement. And then 5, practice with your radio. If possible, try adjusting squelch using memory channel and scanning on a real radio. Hands-on experience makes these questions intuitive. Again, it's real easy these days now to get a $25 radio and you can do a lot of listening and kind of tinkering around and seeing how things work. And then use memory aids. Create mnemonics like RIT, receive it tuned. Flat is where it's at for RF amp hours, amps equals hours. And a lot of these slideshows like the one that I use, you can go online and find those and download them, and they have memory tips included in them. So that's the summary for the T4 section. We hope you've enjoyed this and hope this helps as a study aid, and we'll move on next to section T5.